Hi, my name is Dale, and as Michael said, I'm a mechanical CAD designer for industrial. And I'm an industrial or a mechanical CAD designer for industrial automation. And I'm building a $100,000 self-driving lab that's designed for viability studies for scientists running cell culture experiments. Okay. So my dream is to create a modular, AI-enhanced self-driving lab that has the reliability of a benchtop instrument and the scalability of a traditionally automated experiment. Okay. So during our 100-day fellowship, the keystone instrument that I built was the flask shaker, and that included, sorry, it bounced. Oh yes, there we go. The keystone instrument built was the flask shaker, which included both a touchscreen local control as well as a networked client and administration page. So you can run it either as a traditional instrument or one that might get integrated with a self-driving lab. So the instrument was designed and prototyped for about $100 in components, and then it used equipment that you'd find in a traditional makerspace that's set up for microelectronics and 3D printing. So let's take a quick look at the other instruments. So as you can see here on the left side, we started out with the decapper. And so that was really the first in-depth model that I made. We went into a lot of detail in precisely matching the requirements of decapping for a lot of different cap sizes. And manufacturing of this turned out to be beyond the scope of our fellowship. But I think that the collet design that was integrated into that matches a lot of industrial tools will ultimately be something that I rely on for the entire fleet of decappers. So I think it's much more robust than using a traditional robot arm gripper where there's a lot of calibrating the robot touch points and coordinating the motion. You can have as many of them as you want, and they're much more affordable. So we also made a flask tipper and a mobile robot with a pallet jack there. And that was actually an interesting one. It's part of an iRobot educational kit. And so it also has a block coding module, a traditional coding module, and a lot of additional features. So it can be integrated if you're developing your own DIY lab, and integrated pretty easily into educational kits, if that was what you wanted. So additionally, all right, I worked on some advanced instrument projects like recovering a salvage 6-axis robot arm that had just all the cables cut, building an autonomous gantry-based microscope, and building a block coding interface for an OT1. Okay, and that was all accomplished with Claude. Okay. All right, now as I mentioned, the keystone experiment or instrument here was the heater shaker, okay? And we've got it on the back table there so you can see it yourself. It uses a 3D printed frame that's traditional PETG. I model everything in SolidWorks CAD just because that's what I have my professional background in. But the shapes are very straightforward. As I mentioned, it also has a local touchscreen control, and then it has both the web client and the server administration page. I started building a basic script so you can control the thermal temperature and add safeties. It lets you also integrate the script for spin speeds, spin safety speed so you don't throw anything, and really any other parameters that you might want to add. So all of the electronics here are actually older legacy hobby kits. So you can buy all those pieces and put them together. There's some additional industrial components. The motors themselves are out of old office equipment, like heavy office printers. And those printers really give you a lot of versatility. Okay, there's a ton of motors in them. People throw them away freely. And it's just a 4-wire stepper motor. All right, so a key point of this was building the touchscreen interface and matching it with the web client. So it's something where I needed to calibrate the physical hardware without a ton of experience programming embedded components. So I gave Claude access to photographs of a calibration on the instrument and then feedback from where I made contact. And that allowed Claude to automatically calibrate the touchscreen. And then all I did was match the coil pairs in the motor, wire it all up, and it was pretty much running. Okay. Okay, so as Michael mentioned, I'm not a laboratory scientist in any way, but I was lucky enough to have my fellows, co-fellows available to provide me with some feedback. And so one of the great things about being able to rapid prototype this is that I added the features that they asked for in a weekend. So we added, that's actually just the heater block that I'm going to mill the thermal heater out of. It's going to be basically just like a 3D printer that has a resistive heater under it. It'll have temperature control. And Julia also asked for an angled flask mount. So that's built into it. A lot of people also asked for a lot more simplicity and robustness in their lab automation. And so that's one of the things we're working on. So a lot of lab automation is built on office equipment, and it's not nearly as robust as the industrial equipment that has granite bases or cast iron. And so we're working on low-cost ways to improve that. So this will also integrate with the Blockly design interface, or with, if a scientist had a hypothesis generator, that could output standard code. The driver in this instrument would just convert the universal code to its specific driver module, and you can either drive it with Blockly or have an automatic script. Okay, 30 seconds. Okay, perfect. So as you can see, this is the actual lab in my apartment. You can see the microscope on the end, the serological pipette, decapper, shaker, and the OT1. Okay, in the next couple of months, I'm going to work, using just a food coloring experiment to finish the instruments, make them wash down compatible, and actually start growing some cells so I can eventually work with a proper facility to get a running lab. And there we go. And so yes, that's exactly what I'm hoping to be able to find some help with here. So if anyone is interested, we're looking for fellowship positions or additional kind of after work hours opportunities with people who want to experiment. I, of course, have to thank, there's too many people to name here, but thank you to both my employer, Counterculture Labs Oakland, for helping with the OT1, all of the co-fellows, and of course Michael for putting on the program. Okay. Thank you.